K8BYPs confuse a ham video series. Hams only. I'm afraid I'm not qualified to confuse cats. Yes, I'm a Python freak. From video number 4, where we started making a stab at plate power, we have predicted values from the tube manufacturer and the predicted poor video quality. And in a previous video I showed you how to use measured and verified values from the Drake TR3 and 4 to set up formulas to calculate actual plate power. It is not possible to directly multiply plate voltage and plate current together, because as from the plate curves down here, at the highest plate voltage it's the lowest plate current, and vice versa. These graphs are rough graphs of plate voltage and plate current, represented as sine waves on a similar scaled graph. Similar x scaling, not y. But showing the progression from maximum plate voltage at the top left 2 kV down to minimum 500 and back up over half cycle, and the bottom graph is plate current starting at 0 going to a max of 1.2 amp. It is not possible to take 2 kV or 500 volts and multiply either by 1.2 amp. It will give the wrong answer. They're not like this. It would be possible in that case. They're opposing. So cannot times them together. At no time can they be times together. So what I showed in the last video, we go to integrate those into an average value, and through the magic of capacitive coupling, which effectively scrapes that voltage waveform off the ceiling and references it to ground. Try saying that fast 3 times. If you recall in a previous video, I showed you the integral over the limits of 0 to pi for sine theta d theta comes out to be, from peak, we multiply peak times 0.637, that gives average. That ends up with graphs looking like this. Mathematically, we take the difference of 2 kV and 500 volts, which is what's seen through a coupling capacitor. That's 1500 volt swing, so to speak, and down below 1.2 amp, because the minimum current is 0, so it doesn't figure in. We multiply those through by our magic 0.637 to get average, and that gives 956 volts average for a half cycle and 764 milliamps average per half cycle. Put them together, because now they're the same kind of thing. They're both averages over time, reference to the 0 line. Multiply 956 volts times 0.764 amp, that gives us 730 watts dissipation in a tube over 1 half cycle. Oh my, that's a lot for a 400 watt tube, isn't it? Well, not really. Because if you recall the previous video, this is class B, not class A. It's half cycle. So 730 watts is less than 800, where 800 is 400 max for the tube per full cycle. Pardon the cough. But since it's only dissipating through the tube half cycle, we can multiply that by 2. So the maximum allowed is 800. 730 is clearly less than that, so if those numbers are correct, we've got a margin of safety. From the data sheet, plate current, 400 milliamp DC, single tone plate current. Single tone is that. That's a half cycle of a single tone. Single tone refers to the drive. If we divide that in 2 for half cycle, we get 382 milliamps, which is approximately 400 milliamp from the case information on the data sheet. That kind of corresponds. It's below the maxima. It's a little bit below it, so is the power. We might guess if we calculate the difference in current, we'd probably come up with a difference in power, but you're free to try that on your own. Point 3, 730 watts average over a half cycle divided by our magic number 0.637 from the integral. To convert that back to peak is 1145 watts peak on a half cycle. Now that sounds like, oh, that's a way too big a number for this tube. Well, no, it isn't, because it's peak, and as we proved just above, it's less than max dissipation. But don't freak out because 1145 is so much bigger than 400, because that's an illusion. If you recall, the common term is flywheel, but that's really not a good term. The swinging effect of the plate inductor and other reactances in the system. Doubling that, take 1145, double it, we get 2290 PEP max. The qualifications here are that the case on the data sheet is working into resistive load, and that goes someplace interesting here in a minute. Extremely confusing. So for resistive load with the tube only conducting half cycle, then there's no flywheel or swing effect, and we don't get the number 4, the multiplied by 2. And if we work from there backwards up, we see it's still within limits for 400 watt tubes, so it's still legal. As in the TR3, recall how we started with 52.5 watts plate dissipation max. Let's start with 400 for this tube. Times 2 for class B is 800 watts. 800 divided by our magic number is 0.637 gives 1256 watts half cycle peak. Multiply that by 2 is 2511. So the 2290 we figured from this amplifier is less than 2511 max for the tube. So that qualifies. That's less than max dissipation. Anybody ever seen or heard of a ham that had a 4-400 amp that would produce more than legal PEP limit? I haven't, but this data says that it will do it with ease. Question for you to ponder while I get around to giving the answer is why. But beware of the gremlin. There's an ugly gremlin in the room, which is Miller capacitance, which is in parallel with the plate resistance. And so at 6 meters, that Miller capacitance is basically a short. You can imagine what that would do, throwing a short of 130 ohms across the plate. So this is only valid for low frequencies like tens or hundreds of kilohertz. As frequency goes up, that Miller capacitive reactance goes down, and it starts doing weird things with the phase. It'll throw the voltage and current out of phase, induce a reactive component, and recall from basic electricity, reactive power is not real. It's VAR, volts ampere reactive, not dissipative. So that capacitance doesn't play a part in amplification. In fact, it does just the opposite. It attenuates. The effect of Miller there is to change that plate resistance from the ideal value of 2750 from the datasheet to something else. And that something else is a complex impedance. Most of the part of designing an RF amplifier is dealing with those complex impedances. Now it's important to go back here and reiterate after going through that we cannot multiply 2 kV by 1.2 amp. That gives 2400 watts half cycle. No way. That's that much. Neither can we multiply it by 500, which gives 600. They're both grossly wrong, because realize they're not doing the same thing in the same direction. They're not doing the not case. One more check against the data sheet. Step 3, 730 watts average over half cycle. That's almost 800. Does that kind of jive with the 445 figure in the data sheet? Well, 730 divided by 2 is 365. Just right there, pretty close. Right there, close. We don't know for a fact that our load line is the same case as they used, but A, it's close, and B, this calculation, if it's correct, is on the good side. It's on the less dissipation side, which means less chance of burning the tube up. And that's always good when the tube is $800. And if you haven't been here before or zooming out, this is the step between a technician level operation, where the care and feeding document says that anyone can calculate this if they have some very basic knowledge. This is engineering. This is applying especially principles of calculus to a much more complex set of ideas than just this and doing some simple multiplication with a tube computer. This is what's known as engineering circuit analysis. So if you've not seen or done it before, you've seen it and you can go through and do it, and you will have a little bit of experience in what it's like to do engineering. But the interesting part of that is this is big fun, big accomplishment. It's also a big responsibility if we get the wrong answer, because the engineer has nobody to blame when they get the wrong answer. Been there, done that. The engineer cannot blame the technician. Blame goes uphill. So realize there might be a mistake in any of the videos I put up here. As I mentioned before, these are not rehearsed. I get an idea, I make a drawing, I start the phone right off the top of my head. This is all from memory and Mr. Calculator. But this is what I've learned, retained in my mind. This is not putting together a flashy video. This is real, and this is really the process that I would go through if I were an engineer on a real project, instead of just doing this at home for fun. Which is why I do it like this at home for fun, to keep my skills up.
Well, that's the end of the film. Now here's the meaning of life. Thank you, Brigitte. Well, it's nothing very special. Try and be nice to people, avoid eating fat, read a good book every now and then, get some walking in, and try and live together in peace and harmony with people of all creeds and nations. And finally, here are some completely